Hello and howdy, math enthusiasts. We're up to question number 22 on the 2001 Fermat paper. The Fermat paper, of course, put out by the University of Waterloo. And question 22 says, a sealed bottle, which contains water, has been constructed by attaching a cylinder of radius 1 centimeter to a cylinder of radius 3 centimeters. So here we have the smaller one, and we have attached the larger one. Okay, as shown in figure A. When the bottle is right side up, the height of the water inside is 20 centimeters, as shown in the cross-section of the bottle in figure B. When the bottle is upside down, the height of the liquid is 28 centimeters, as shown in figure C. What is the total height in centimeters of the bottle? Okay. It's an interesting little question. Now, we're given these cylinders, we know their radii, but we don't know their heights. Okay? So what we could do is we could give them heights. I think that's what we'll do right now. Well, first we'll get ourselves a brand new piece of paper, and then we'll give them heights. So here's the small cylinder. And then here comes the big cylinder. So we'll let the top one, we'll leave the blue for water. We'll let the top one have a height of little h, and the big one have a height of capital H. And we'll let their radii be, well, we know their radii are 1 and 3, but I would let them be little r and capital R respectively if I didn't know them as well. Okay. So before we go any further, we want to find h plus h. Okay? That's what we'd like to find. So that will represent the total height here. And what information are we given? Well, we're given... Now, I never know how much to trust these cross-sectional figures. If you look at figure B, if it's right side up, it looks like it fills up the bottom one, and then it's got just the tiniest bit of the top one. And here in figure C, it looks like we have the smaller one is completely filled, and then we have a large portion of the bigger cylinder filled. So based on figure B and figure C, I would guess, so the thing that we have in common here is the volume of the water. Okay? So we can get, using figure B and figure C, we should be able to get two formulas for the volume of the water, set them equal, and we should be able to possibly work out little h and capital H, but at the very least, we should be able to work out their sum. Okay? So we're going to need the volume of a cylinder, and if you don't remember what that is, that's okay. Volume of a cylinder is the base times the height. Okay. Now we know the volume of the water. Stays constant. So if we have figure B here, so we have a height of 20 here, and based on the figure, we are led to believe that capital H is less than 20. That's the belief here. So we have capital H, and then we have 20 minus H here. Okay? Now this is still the height of a cylindrical section of water. So we'll be able to use the formula for a cylinder on both of these. So we'll have pi 3 squared h plus pi 1 squared 20 minus h should be the volume of the water. And that was figure B. Now what about figure C? In figure C, we have the bottom one is entirely full. And then we have a large portion of the top one is full. And the water will, thanks to gravity, settle nicely and have a flat top here. So, told that this is all 28. This down here is h. So this should be 28 minus h. So the volume of the water should be, well, the full cylinder. So that's pi. What's the radius? Well, we're told it's 1. And then h. And then the big cylinder filled up 28 minus h. To that particular height in centimeters. Now both of these should be equal. So we're going to set them equal on the next page. We'll take out a factor of pi here. 9h, and then we had plus, it was 1 squared 20 minus h. And that should be the other volume of the water, which again, we'll take out a factor of pi. And it'll be h plus 9, 28 minus h. Alright, we'll just double check that we have those right before we proceed. No sense in getting our equations wrong. Nope, it looks like everything's good. So we can divide both sides by pi. That's not going to make a difference. And we can clean up the left-hand side. There's 9h and this minus h. They're going to cancel out. So 8h plus 20. And we should have h. Well, there should be a little h here. Yeah, there's a little h over there. I just screwed up a little bit. So this h plus, well, what's 9 times 28? So plus 252 minus 9h. Well, I can clean that up into 252 minus 8h. Alright, so let's get our constants over on one side and our variables over on the other. We're going to get 8h plus little h. And 252 minus 20 is going to be equal to 232. So let's divide both sides by 8. And we'll be left with a total of 29. So we weren't able to figure out little h and capital H, although maybe with some extra work we could. But we know that big H plus little h, which is the height, which is what we wanted, that's all we were after, was 29. So 29 centimeters tall. And let's see what we can do here. A, 29. Okay. So that was question number 22, an interesting little question. We had to rely on the information from the figures. If we didn't have these figures, we wouldn't have been able to guess that a little bit, figure B, we have the bottom cylinder completely full and then just a little bit in the top one. We wouldn't have been able to work that out. Yeah. I think that's it. So we had to rely on the pictures, but it was we needed to know a little bit of the information about volume of a sphere, or not volume of a sphere, volume of a cylinder. But in the end, it all worked out, and we got our final answer of 29 centimeters. So, good question overall, and hopefully you'll join me for the next one, which is question number 23, which we'll take care of in the next video.